And it's tough where you can see things. I don't think that the exact right call is being made now, because in many ways Sony's position was development effort does not matter. And that was the position through the PS2 and the early PS3 design, where they picked a direction and said the hardware is difficult and challenging to program for, but developers will suck it up because we're Sony and that's what they have to do. And it works okay for them, but I think they're feeling a little bit of a pinch on that. But the fact that something that's that far off the development ease and robustness, stability, and all that can be the way one of the dominant platforms is being pushed here, I don't think we're going to have a complete reversal and backtrack on that. I think that looking for peak performance is going to be incredibly important. And unfortunately, where we're going in the next generation, and I've got my 1 hour in warning here, but we'll talk about next generation stuff and then go to questions on this. We do have a plan for next generation technology. I think that what the big play for Intel 5, the hook that everybody looks at is this virtualization of texturing, unique texturing on everything, and we're getting good results with it. It is what I expected it to be. The artists are learning how to really do some excellent things with it. Uncorking the limitations on texturing has been good. And I comment on this and how it's unfair, basically, that this gets all of the attention, where people focus on the visual things. But, the rendering section of the code, let alone my part of that code, is such a tiny fraction of the code. When we wound up getting the whole thing together for this code analysis tool, my God, there's a lot of code in all of this. There's a lot of work that goes into all of these different sections of code. We sure hope that we're going to be able to reuse a lot of that code going forward. We think that what we've got in terms of animation, AI, game logic, physics code, these things will evolve, but we hope that we don't have to just open the big trapdoor, pitch everything out, and rewrite something to fill that spot coming forward in the next probably 2 titles. But we do think that there's going to be a next generation graphics engine to define Intel 6. And this is lots of hand-waving speculative stuff here, because the hardware that we're positing to develop something for fundamentally does not exist right now. We have the glimmers of what it's going to be. We've got Intel's direction with Larrabee. We've got what's going on with CUDA, what's going on with Fusion. These are sort of the things that people have to pick from. And we've got a lot of players here. We've got what happens in the PC space. There are people that honestly believe that the PC will come back and make consoles obsolete. I think that probably is a naive view. I think that there are inherent challenges to the PC platform that the consoles don't have, that I would be surprised to see the set-top PC box really making Sony and 360s and Wii's and everything obsolete. I don't think that's going to happen, but it's a player. The PC space is still relevant there. And then we have the normal big guns in this, where you've got Microsoft, Sony, and Nintendo. And of course, it's exciting to see how well Nintendo's done, because people were counting them out at the last generation, that they're going to be the next Sega, and here they go, and they've really kicked everyone's butt this generation. And I've never been, Nintendo's always been our kind of least friendly first party on there, but I cheer success. I cheer anytime they went against the conventional wisdom, they did something different, and they won big, and that's been great to see. But what happens with all of these vendors on the next generation, the timing of all of this is going to be interesting. And we know a little bit more now than we did a year ago, but not a huge amount more. We kind of know internally sort of how many steps away the 3D hardware vendors are from where they think they'll be pitching for next generation consoles, which lets us sort of back figure roughly what time frame we're looking at. And honestly, it would be great if this generation of console lasted twice as long as the last one, if we had a viable 8-year commercial lifespan for this generation of titles. And I know some people are saying that this is the plan. I don't think it's going to turn out that way. I think it's going to be far too tempting to want to one-up your competitor by jockeying such that they don't think you're doing this, but you really are, and you're going to get it out earlier and get some first mover advantage. So I don't think it's going to be too long. I hope it's long enough that we're able to have the Doom project come out and a nice good sweet spot on this generation, and it's not when everybody knows what's coming next Christmas and is holding off on things there. But this generation on the consoles, there's a kind of nice thing, Power PC across the board, and that's just fine with us. We don't have, the processor architecture doesn't make much difference to us nowadays. There's not that much code that's low-level specific. Unfortunately, the cell complicates the issue on the PS3. But for the most part, it doesn't make that much of a difference whether we're programming for x86 on the PC or PowerPC on one of the consoles, multi-core on the PC versus multi-core on the 360. It all works really pretty nicely together. It could get kind of ugly as we look towards the next generation, depending on how the decisions play out. And I honestly don't know exactly what my dream scenario would be. There's certainly the possibility that one vendor could win big. And I'm sure Intel is certainly, I'm sure they're all pushing for that, but probably maybe Intel more than most about win big with Laramie on there, go out across the board. I have no inside information on what they may or may not try to do with that. But on one hand, it would be kind of cool from a game developer standpoint if consoles were fairly common in architectures and they just had different numbers of processing units and you could kind of scale across. Maybe Nintendo does do the mass market consumer version with less processing power, while Microsoft and Sony still go head-to-head in the battle of subsidies to see who can put the most powerful thing out at an acceptable price point there. That might be one vision of the future which could be pretty nice for developers. But going to the stakes are really high, and if we did wind up with a monoculture there might be some downsides to it. I mean, I do have some opinions on the actual technical merits of Laramie versus future CUDA derivatives there, and it's, in the few days of research that I've been able to devote to some of this, I did finally have a few of the little light bulb moments go off about how I need to restructure future code to work properly on these types of SID-DC and processor architectures on there. And I'm in an interesting situation where I've been concerned about this massive parallelization a lot, about how this requires very wide vectors to get good performance, and everything is this 16, 32, maybe more vectors wide, and there are huge classes of applications that just do not work well on that. And there's going to be massive amounts of stuff that will be running on these systems using literally 1/10 of the processing power that it's got available, or less. I mean, there will be significant applications using less than 10% of what you should be able to get out of this. And the specific application that I've been thinking about was this sparse voxel tree raycasting stuff, which is a research project that I started years ago when I got to revisit it a little bit this year and look back over some of the elements of it. And there was this interesting moment when I realized how this particular algorithm that I'm worried about actually does parallelize well across SIMD architectures. And it was one of those things where I did not appreciate the difference between a really wide SSE or AltiVec type thing. There's lots and lots of things you can't do because all the memory comes in, the blocks that are right next to each other. But the real difference in the upcoming architectures is this memory scatter and gather so that every element can fetch from a completely different memory location. So really all you have to do is prevent them from diverging. If you can run across the same code paths continuously, the data can be doing anything that it wants, and you can do all sorts of things to get it back together. And my particular pet algorithm is going to work pretty well on that. And I'm in a situation right now about worrying that, does this mean that lots more of these algorithms really just need that little mental gymnastics to realize how it works? And I don't think that's the case. I think that the truth still is that the vast majority of them do not parallelize well across SIMD, and I got lucky with the fact that this direction that I was looking at happens to work okay. But the jury's really still out on that. If we look back the last couple of decades, people have been researching parallel processing for all this time in universities. Lots and lots of papers have been written, books have been written, lots of work, and the results really have not been all that impressive. The most impressive parallelization that we've ever gotten in the industry by far is vertexes and fragments with graphics processing. That's why I'm still hesitant to say that a lot of people are just thinking, oh, polygons are going to go away, we're going to be doing all this other crazy stuff. And I can say with conviction at this point that the next generation games are still going to be predominantly polygon games. Even what we're looking at for Intech 6 with all of this infinite geometry, voxelizing everything, probably recursive automatic geometry generation down there, all this is still going to be a hybrid approach where we would hope that we can generate these incredible lush environments on there, but the characters are probably still going to be coming in as triangles over skeletal deformed skeletons there. And There will probably be some interesting things tried with completely non-polygonal renderers, but the practical approach for people that are doing games that look like the games we're doing now, only better, probably will still have lots of polygons going on, and these chips better be really good at that. So this, you can actually,